Welcome to Lesson 1, the Capital Asset Pricing Model and Arbitrage Pricing Theory with Multi-Factor Models in Course 2. In Session 1.1, you will learn the basic principles of the Capital Asset Pricing Model, CAPM. The learning goals for Session 1.1 are: you should be able to apply the Capital Asset Pricing Model, CAPM, and its assumptions. You know the concept of beta and combination with the risk premium of the market portfolio. Students should be able to use the security market line to evaluate if securities are fairly or not fairly priced. The capital asset pricing model is a set of predictions concerning equilibrium expected returns on risky assets. Harry Markowitz laid down the foundation of modern portfolio management in 1952. The CAPM was published 12 years later in articles by William Sharpe, John Lindner, and Jan Mossin. The CAPM is based on two sets of assumptions. The first set pertains to investors' behavior and assumes that investors are alike in most important ways, specifically that they are all mean variance optimizers with a common time horizon and a common set of information reflected in their use of an identical input list. The second set of assumptions pertains to the market setting, asserting that markets are well functioning with few impediments to trading. All assets are publicly held, short positions are possible, no taxes and no transaction costs arise. It is important to understand these assumptions. Understand later how these models may change when one or more of these restrictive assumptions are relaxed or violated. The efficient frontier and the capital market line. Remember from the previous session, having focused on the capital allocation line, investors would draw an identical tangent and naturally all would arrive at the same risky portfolio P. All investors therefore would choose the same set of weights for each risky asset. Ask yourself what must be these weights, because the market portfolio is the aggregation of all of these identical risky portfolios. It too will have the same weights. Therefore, if all investors choose the same risky portfolio, it must be the market portfolio. That is the value-weighted portfolio of all assets in the investable universe. We concluded that the capital allocation line based on each investor's optimal risky portfolio will in fact also be the capital market line. The market portfolio M is the value of the aggregate risky portfolio, which will equal the entire wealth of the economy. The market risk premium. Recall that each individual investor chooses a proportion Y allocated to the optimal portfolio M, such that Y is equal the market risk premium divided by the investor's risk aversion times the portfolio variance, where the following term is the risk premium or expected excess return on the market portfolio. In the simplified CAPM economy, risk-free investments involve borrowing and lending among investors. Any borrowing position must be offset by the lending position of the creditor. This means that the net borrowing and lending across all investors must be zero. Therefore, rearranging this formula to the expected market premium, the average position in the risky portfolio is 100%. Therefore, substituting Y equal to 1 into the formula, we find that the risk premium on the market portfolio is related to its variance by the average degree of risk aversion. Return and risks for individual securities. The CAPM is built on the insight that the appropriate risk premium on an asset will be determined by its contribution to the risk of investors' overall portfolios. Portfolio risk is what matters to investors and is what governs the risk premiums they demand. Remember that in the CAPM, all investors use the same input list, that is the same estimates of expected returns, variances and covariances, and therefore all end up using the market as their optimal risky portfolio. Individual securities example. Let's do an example of how to measure the contribution of General Electrics to the risk of the market portfolio. The formula of the contributions of GE stock to the variance of the market portfolio may be stated by the following formula: the sum of its weighted covariances. If the covariance between GE and the rest of the market is negative, then GE makes a negative contribution to the portfolio risk. By providing excess returns that move inversely with the rest of the market, GE stabilizes the returns on the overall portfolio. If the covariance is positive, GE makes a positive contribution to the overall portfolio risk because its returns reinforce swings in the rest of the portfolio. We also observe the contribution of GE to the risk premium of the market portfolio. It can be expressed as GE's contribution to the risk premium divided by GE's contribution to the variance. The market portfolio is the tangency on the efficient mean variance portfolio. This ratio is often called the market price of risk because it quantifies the extra return that investors demand to bear portfolio risk. Continuing on the GE example, a basic principle of equilibrium is that all investments should offer the same reward to risk ratio. If the ratio were better for one investment than another, investors would rearrange their portfolios, tilting toward the alternative with the better trade-off and shying away from the other. Such activity would impart pressure on security prices until the ratios were equalized. Therefore, we conclude that the reward to risk ratios of GE and the market portfolio should be equal. To determine the fair risk premium of GE stock, we solve the previous equation for the expected risk premium of GE in the following formula, which is the covariance of the risk premium of GE and the risk premium of the market divided by the variance of the risk premium of the market times the expected risk premium of the market. The ratio measures the contribution of GE stock to the variance of the market portfolio as a fraction of total variance of the market portfolio. This ratio is called beta. Expected return beta relationship. Replacing the ratio with beta of GE in the previous formula and the expected GE risk premium with the expected return of GE minus the risk-free rate, we receive the following term: the risk-free rate plus the beta times the market risk premium. The CAPM predicts that systematic risk should be priced, meaning that it commands a risk premium, but firm-specific risk should not be priced by the market. Writing out the CAPM for each stock and multiplying each equation by the weight of the stock in the portfolio, we obtain the expected return on the portfolio and the portfolio beta. Incidentally, these results has to be true for the market portfolio itself, as shown in the following formula. In a well-functioning market, investors receive high expected returns only if they are willing to bear risk. The market beta is equal to 1. Expected return beta relationship. Replacing the ratio with beta of GE in the previous formula and the expected GE risk premium with the expected rate of return from GE minus the risk-free rate, we receive the following term. This formula is called the CAPM. The CAPM predicts that systematic risk should be priced, meaning that it commands a risk premium, but firm-specific risk should not be priced by the market. Writing out the CAPM for each stock and multiplying each equation by the weight of the stock in the portfolio, we obtain the expected return on the portfolio and the portfolio beta. Replacing the expected return and beta for GE with the market terms, we receive the market portfolio itself, as shown in the following formula. In a well-functioning market, investors receive high expected returns only if they are willing to bear risk. The security market line. The expected return beta relationship can be portrayed graphically as a security market line SML. Because the market beta is 1, the slope is the risk premium of the market portfolio. The capital market line graph the risk premium of efficient portfolios as a function of portfolio standard deviation. This is a valid measure for risk for efficiently diversified portfolios that are candidates for an investor's overall portfolio. The security market line, in contrast, graphs individual asset risk premiums as a function of asset risk. The relevant measure of risk for individual assets held as part of well-diversified portfolios is not the asset standard deviation or variance. It is instead the contribution of the asset to the portfolio variance, which we measure by the asset beta. The SML is valid for both efficient portfolios and individual assets. On graph 2, in a market equilibrium, all securities must lie on the security market line. We see here how the CAPM may be of use in the money management industry to assess if a security is fairly or not fairly priced. If you look at this example, let's assume that the stock currently trades at 17. We can calculate the expected return given by the SML. So we take 6% for the risk-free rate plus 1.2 times for the beta times the market risk premium, which is 14% minus the risk-free rate of 6%. So we arrive at an expected return of 15.6%. As we are looking for positive alphas, this would be a good buy. The alpha is the 17 minus the 15.6, which is equal to a positive 1.4%. Single index model and realized returns. The index model states that the realized excess return on any stock is the sum of the realized excess returns due to market-wide factors beta times market premium plus a non-market premium alpha and firm-specific outcomes summarized by E. The logic of the KPIM is that the only reason for a stock to provide a premium over the risk-free rate is that the stock imposes systematic risks for which the investor must be compensated. Investors will short sell negative alpha stocks, driving down their prices and driving up their expected returns. This portfolio rebalancing will continue until all alphas values are driven to zero. When all stocks have zero alphas, the market portfolio is the optimal risky portfolio. Liquidity and the CAPM. One of the CAPM assumptions are no transaction costs and liquid assets trade on public exchanges. Liquidity, of the lack of it, has long been recognized as an important characteristic that affects asset values. An important component of trading cost is the bid-ask spread. Let's have an example. If the bid price for a stock is 19 and the ask price is 20, the bid-ask spread is 1. You can express this as a percentage. This would be equal 1 divided by 20 or 5%. There is another great emphasis today on the components of the spread due to asymmetric information. Asymmetric information is the potential for one trader to have private information about the value of the security that is known to the trading partner. The relationship between illiquidity and average returns. When trading costs are higher, the illiquidity discount will be greater. Of course, if someone can buy a share at a lower price, the expected rate of return will be higher. Therefore, we should expect to see less liquid securities offer higher average rates of returns. The graph shows average monthly returns for stocks stratified by bid-ask spread. The difference in returns between the most liquid stocks, lowest bid-ask spread, and least liquid, highest spreads is about 0.7%. This is just about the same magnitude as the monthly market premium. This clearly amplifies liquidity matters for asset pricing. CAPM and academia. Testing the CAPM is surprisingly difficult. The assumption that the market portfolio must include all risky assets in the economy. In reality, we cannot even observe all the assets that do trade, let alone properly account for that do not. The theoretical market portfolio, which is central to the CAPM, is impossible to pin down in practice. CAPM and the investment industry. The graph shows a study by Burton Malkiel, who estimates alphas values for a large sample of equity mutual funds. The distribution of alphas is roughly bell-shaped, with a mean that is slightly negative but statistically indistinguishable from zero. On average, it does not appear that mutual funds outperform the market index, the S&P 500, on a risk-adjusted basis. The study reconfirms that professional investors, on average, do not outperform passive market indexes. This result is important. While we might expect realized alphas of individual securities to center around zero, professionally managed mutual funds might be expected to demonstrate average positive alphas. Funds with superior performance should till sample the average to a positive value. The small impact of superior funds on this distribution suggests the difficulty in beating the passive strategy that the CAPM deems to be optimal. We are at the end of session 1.1 of course 2. After having carefully studied the slides and the relevant chapters in the book, please start with the review questions.